Okay, now members, we are going to see how do we handle surds. Surds is our topic we are going to handle today. Let us see what happens in surds. So, surds, we start with the definition. These are irrational numbers which cannot be expressed as integers, terminating decimals, or recurring decimals. I think you know what a terminating decimal is. A terminating decimal is something like 0.25, which is a quarter, 0.75. Those are terminating. It ends with specific decimal places. Or recurring decimals. These are the ones which we know that it's not ending, but at least there's something recurring, like a third, which is 0.3333. Those are recurring. So if you are not that, then we say you are a surd. Then, like this number is root 2, you see it's going to give you something 1.41 and so on. These ones, they are not terminating, they are not recurring, and they are not integers. They can be expressed as integers. So, those are surds. But most cases, if this is a number, just most of them are going to be prime numbers. Most of them, quote me well, most of them. Okay, that's not the properties of surds. Let A, B, and C be positive rational number. Now, rational number is any number like 2, 3, 4, 5. Now, if you put under root, now that one becomes irrational. Hope you have got the difference. Then, root A times root B, we can multiply two integers. I mean, you can multiply these two numbers and the root if all of them are in the root. So, we say root A times root B. Then root A times root A, using this property up, we can multiply this and this. You get A squared, and this is that. So meaning, always root A times root A gives us an A. Then if you have two surds dividing each other, it's the same as putting them under one, then be root A over B. Then how do we add? If you have, we add only if this and the root is the same. So this should be the same. So if this and these are the same, then you can add A plus B. How do you subtract? The same idea. You get A minus B there. We only add or subtract if one is under root is the same. If it's not, there you can't do anything. Let us go through these examples here. Simplify the following. Now we see that here we are adding. So you ask yourself, can I do anything? Yes. Why? This is 2 and this is 2. So it's root 2 and root 2. So you can easily add these ones. So this will be now 2 plus 3 to the whole root 2. Using this idea. You add the coefficient. So you add this coefficient plus this coefficient. And so here I'm getting 5 root 2. And there you have simplified that. Now here root 3. I mean root 3 and root 3. So there I can add. The coefficient there is 3. Here so we have 1. So instead here we have 1. So I'll be having now 3 plus 1. Instead here there is a silent 1. Then under root 3, which will give you a 4 root 2 3. When you come now this can we subtract? Yes, under the same root, we have the same under root. So you can easily subtract. You just say 4 minus 2, you get 2, now root 5. So this will be 3 minus 1, which will be now. This one, so what is under a root is 2, then this one is 8. Now, always you just ask yourself, what is the easiest prime number here? Always this one is embedded in with a prime number and a square number in most cases. So this root 8 will be the same as root 2, this one, minus now root 2. This is going to be the same as 4 times 2. You get this divided by this, you get 4, so it will be 4 times 2. And we say, now this will be, you can separate, this will be now 3 root 2, then minus root 4 root 2. And this will see we have 3 root 2, then minus root of 4 is 2 root 2. And start here, you can easily simplify. 3 minus 2, we get root 2. I repeat, you see that this 8 here, you ask yourself, is this 2 inside this 8? Yes, when you get 8 divided by 2, you get 4. Meaning if you get 8, you get 4 times 2. Now, you can express now, say, if you multiply two numbers like this, you can come and separate them as we have done. done here. You separate root 4 and then root 2. Root 2, root 2 is irrational. Then root 4, you can get the integers too. Then you subtract 3 minus 2, you get 1. And that. Now when you come to this now, you ask yourself, now this one we are going to deal with always integers. Integers, but these integers specifically prime numbers. You ask yourself, is there a prime number that can divide this and give you a square number with it? No. So yes. You see that a 2, when I get here 2, I get 10, which is not a square number, so I go to 3. Divide here by 3, that's what you divide, so that's not going to work. When I come to the next prime number, which is 5, 5 divides 20 4 times. Does it divide this? Yes, 10 times. Is 5 dividing this? Yes, 9 times. Meaning that this one will be now root of this is that the prime number that is contained in this 3 is a 5. So 5 divided here is 4. So this is 4 times 5. Then plus 5 divided here will be a 16 times 5. Then minus 5 divides this 9 times. So it will be 9 times 5. So you always first step through using these prime numbers. So here you said you can separate root 2. This will be now root of 4 times root 5 from here. If you have this, you can express it like this. Then plus root 16 times root 5, then minus root 9 times root 5. So root 4 is 2, root 5, then you get this times that. Then plus root 16 is 4 times root 5, you get 4 root 5. Then minus 3, root of 9 is 3 times root 5. You see that here? The same. So you can add 2 plus 4, we get 6. 6 root 5. Then minus 3 root 5. When you are mature enough, you can move this in one step and you get the final answer. So here, the same. So you can subtract 6 minus 3, we get 3. So this will be 3 and root 5. As simple as that. When you come to this now, you have the prime numbers. So you can put them here 2, 3, 5, and so on. Does it divide this? Yes. Is it divided to give us square number? Yes. Square numbers, square numbers are 1, 4, 9, 25, like that. Those are the square numbers we're talking about. So it's like 2 divides this, and 2 divides this. But the common thing is it's dividing all of them and it's also giving them with a square number. So now you say 2 divide this, you get 16. So this will be now root 16 times 2. When I multiply this, I'll come back to that. Then plus root 2 divided this 9. So that will be 9 times 2. Then minus root. This 2 divided here, you get 25, then times 2. So that the prime number that was working for us here is a 2. Then you ask yourself, the square root of 16 is 4. Square root of 2 is not there. It's rational. You leave it there. Then plus, square root of 9 is 3. Then square root of 2 is irrational. Square root of 25 is 5. Square root of 2 is root 2. As simple as that. Then you simplify. I'm to put my signs there. 2. Now it's that this is the same and this is the same. So you can add 3 plus 4. You get 7 root 2. Then minus 5 root 2. Then you see 7 minus 5. Because these are the same, so I can subtract the coefficient C. So 7 minus 5, I get 2 root 2. As simple as that. Then we come to this, we ask ourselves, is 2 dividing all of them? We test using prime numbers. Is 2 dividing this? Yes. Is it dividing this? Yes. Is it dividing this? No. So 2 can't work. We move to the next one. Is it 3 dividing this? Yes. Is 3 dividing this? Yes. Is 3 dividing this? Yes. So meaning that is 3 this going to work for us if it's dividing all of them and it's giving us a square number. So we said that this would be 3 divided 48, you get 16 times 3. I think we see that our 3 is working now. When you get 3 divided by that, you get 4 times 3. This will be common to all. 3 divided by this, you get 9 times 3. I think you see 3 is common throughout and it's giving us square numbers. Square numbers we're talking about are the square numbers. Square numbers we are talking about are, these are 1, 4, 9, 16, 25, 36, and so on. Okay, from here you just ask yourself, square root of 16 is 4. Square root of 3, we can't get it as an integer, so we leave it like that. Then minus, square root of 4 is 2. Square root of 3, you see that you can't get a perfect integer, so we leave it like this. Then plus, square root of 3 and square root of 9 is 3. Then square root of 3 remains there. So now can you simplify? The same, so you can add and subtract. 4 minus 2, we get 2 root 3, then plus 3 root 3. Then we see the same, so we can add 3 plus 2, we get 5 root 3, and that becomes our answer. So members, for now, that's what we have. We are going to see more examples about how they can simplify, how they can give you more of this. I wish you well.